All right. So basically, I'll be taking you guys through unit testing, force testing, integration testing, and fork testing. So now, I would like to probe your prior knowledge of testing. I want to believe we've all written smart contracts in Solidity. Is that correct? Or this is just our first time writing smart contracts in general? If you want to say something, please unmute your mic and talk.
Not my first time writing Solidity smart contracts before.
Okay, so every other person have written Solidity smart contracts, right? And
Yes.
we've got test cases for it. Is that correct?
Yes, for Solidity.
Awesome. So can someone give me like the differences between unit testing and force testing, integration testing, and fork testing? Just like I just need to like probe our prior knowledge of smart contract testing. Unit testing, integration testing, force testing, and fork testing. Anyone can give me the differences between these four test mechanisms? Okay, Sabo, can you go first? Do you have any idea how unit testing work? What unit testing is?
Unit testing is like testing your code in bits to see if they work, like if they work the way they are supposed to work, if they behave the way it's meant to behave.
Wait, what? Say that again.
I said unit testing is testing your code in bits to know if it really behaves the way it's supposed to.
Okay, so Daniel, do you agree with Sabo?
Yes. But to add to that, yes, in unit testing now you test a particular code snippet. That's why it's called unit. So you're testing units of codes. But then I agree to him. That's how it is.
Okay, cool. So what differentiates that? I'm still on you, Daniel. So what differentiates that from integration testing?
Honestly, I've not run integration testing before. So
Okay. Okay. So Victoria, do you okay. Okay, Victoria, please go ahead. Do you care to like share the differences between integration testing and unit testing?
Okay, so I think you mentioned four tests. I didn't hear those ones. I couldn't get like what they're called, but my own understanding of unit testing and integration testing, sorry, like based on my knowledge of front end. So unit testing is basically testing lines of code, like let's say a function, right? To test how just one single function works. Then integration testing is when you want to test the whole flow. Let's say you're writing a to-do smart contract, you want to test how the add function works with the remove function, with the, the whole integration of the to-do to make sure that it is working. While unit test, that's integration testing, but unit testing is testing just one particular unit of your code, just a function or yeah. Okay.
Okay, thank you. So Emmanuel Akalo, do you agree with Victoria?
Yes, I agree with her.
Okay, awesome. So can you shed more light on how these two different kind of testing differs from force testing?
I think I'm hearing of force for the first time here, and
Force, F-U-Z-Z.
oh, false. I have
Yes.
no idea about that. Well, I've seen it before, but I have no idea about that. I think it has to do with like interaction with like the contract when it has been deployed, something of that nature. I don't know.
Okay, I don't exactly agree with you, but so anyone with a contrary opinion as regards force testing?
So that is like stress testing your code to see where it fails. So you just when you did stuff to it, you get where it fails. That's just what us.
Okay.
That's why I'm.
So Emmanuel, did you catch that?
No, sir, it wasn't audible enough. I could barely hear
Manuel,
you.
can you say that again?
Okay, I was saying first testing is like stress testing something where you run repeated codes with different values with on your codes to see where it fails. So it's like you're testing an app with 1, 2, 3, 4, 5, 6 till maybe it fails at 100 million. So like that's what we call like first testing. That's what I understand by first testing, not
All
that's
right.
what we call.
So Emmanuel, did you catch? Good. Did you catch that, Emmanuel?
Yeah, I do.
Oh, cool. So, and that that leads us to fork testing. Anyone with the idea of how fork testing works? When we say we want to like fork the mainnet, what do we mean? Anyone?
Okay, so it's we've done something like that at the Berkshire Bridge course that just ended. So it's just basically means um when something is on the mainnet, so you want to do like a rerun of how it will look on the mainnet, right? Just like bring it locally, then test it as if it's on the mainnet before you actually put it on the mainnet, just to see how it will work if it's actually on the mainnet. So you have like this post like test environment that you can use as if you're on the mainnet. So just basically hooking something and bringing it locally to test how it will really work when it goes live. That's what's just.
Awesome. So did everyone catch that? Or do I have to reiterate? So in the course of the class, if we don't understand something, please do well to call my attention to it. And I will be asking a whole lot of questions, right? Because I'm working with the premise that we all have an idea of how this whole thing works. And the only thing we're just doing is testing our contracts and building on our existing knowledge. So with the whole forms of testing we talked about just now, we'll be touching them one after the other. So we'll be starting with unit testing. So let's I want to believe we all have Stacknet Foundry installed on our local machines, right?
Yes.
Okay.
Yes, sir.
Okay, so I kind of prefer sound feedback compared to the thumbs up. So like I can't keep like switching screens, like check if you're sending thumbs up. Do you understand? So can you all see my screen? Is it clear enough?
Yes, it is.
It's tiny.
Oh,
One more zoom in.
Yeah.
all that. Is that okay?
Cool.
All right. So make entry test class. So yeah, I said I believe we all have Stacknet Foundry installed on our local machine, right?
Yes.
Yes.
Okay, so I believe we all know how to initialize a new Foundry project. So oh, one moment. So we have our project initialized. So yeah, so let's take this off. So for now, this was wrong. Is this okay? Awesome. So starting with unit testing, basically, we were trying to check how each section of a particular the whole product as a whole. Now you're trying to test each function to see how they work, to see if they are working properly as expected. So let's say we want to test. Let's say normal unit testing. So let's say we have a simple function that basically say add two numbers together. So let's say function add. So we felt say 5. So we have so we felt so this returns the first two factors. So that returns the summation of A plus B. Right. So now we want to test if this function works, right? We can basically write our test cases inside this single file since it's just basic unit test, right? But to get started, you need to specify the test keyword over here.
Sorry, sir. Please, can you
Okay.
zoom in more? Like, I can barely see.
Well, now, is that okay?
More.
More?
Yes.
Okay, I can. Okay.
Yes,
All right.
it's better. Yes, thank you.
So we want to basically, we're writing our tests inside the same file as our function, right? So we have to specify this, else the compiler will be to pick it up. So then we have to put it in the mode, say tests. So now we want to test if this function works as expected, right? And I want to believe that you are familiar with the super keyword. So can someone tell me what this does? The super keyword.
It's used to access something outside of a module.
Basically above. Thank you very much for that.
Yeah.
So now we now have access to the add function inside our test block over here. So we can go ahead to test our function. So basically you'd wonder if we do SNForge test, how would the compiler pick up our test cases? So we can do that by specifying the test keyword on each of those functions. If you don't specify this test keyword on each of those functions, you won't be able to it won't read this as a test function. So we specify the keyword on line 10 over here, and then let's say function test add, and can have this. Please, if you get confused at any point in time, call my attention to it, right? So, and then to check the validity of our sum, we need to make use of the assert keyword. Please, I'll be calling people at random to ask questions just to be sure you guys are following. So, Daniel, are you familiar with the assert keyword and what does it do?
Okay. Yeah, I understand that. Okay, just like in Solidity, instead of assert, now we're going to use maybe instead of like in Solidity, it would have been require or something like that. But here is to assert. That is, I don't know how to say it, but it's the substitution for the how do I say it now? Okay, if it was Solidity, it wouldn't be assert we use, even though we have the assert statement in Solidity, but here I think it's only assert we use to test. That is to check, between two values or something like that.
Okay, thank you. Sabo, want to give that is it Sabo or Ajidoku? Which one do you prefer? Are you on call?
Yes, I'm on the phone.
All right,
using
you care to give-
my
Yeah, one. Sabo is first or achieve.
Sabo is fine.
Yeah, Sabo is fine.
All right, go on. So do you care
So,
to give it a shot? What the function?
The
Why we need a
assert.
start?
Okay, we use assert to, like, when we want it to proceed, when the condition is true. Like, the condition has to be true for it to pass. That's when we use assert.
Good. That's a perfect answer. Thank you for that. So now we want to like okay. So we want to make sure that our function works perfectly fine, because our expectation is that when we have 2 and 3 together, it should give us 5. And if this is wrong, that means our function is incorrect, is faulty, is buggy. Incorrect. So, of course, we all know that if we add 2 and 3 together, it should give us 5. Anything contrary is going to fail. So, system is still big. So, let's run first. If you run our test, you run your test with SN4 test. That's the keyword that you run your test, and the compiler is able to pick up this test case because of this test keyword that we specify on the function. And you have to make sure that if you are naming your test, it has to like start with test. Let's say you want to like test subtraction now. It has to like test subtraction, test if it works, test has like come before the keyword. And you can see our actually no. Not picking up the tests. Not yet. Okay, yeah, that's right. Yeah. So technically it's running one, our test is not in here, right? So you picked up 0 tests from there, and then 1 test from here, which is running 1 test from source. So yeah, that means our function works. So let's say we have 6, right? Of course, this is definitely going to fail. Let's run this again. Test. So you can see it's definitely going to fail. So this is one of the ways to do a unit testing. So I'm sure if you've been working well with Cairo Smart Contract, you must have seen a function that panics, function that fails and stuff like that, and a function that you expect to fail. How can you handle functions like that? So let's say we have a function that is expected to fail. Okay, for example, now this function, now we expect it to fail, but then we don't want it to return to us like this. Do you get? So if you're expecting a function to fail, let's have this. Let's return this back to 3. So let's say we have a function that we expect it to fail. So in test fail at. So now in StackNet Foundry, we have the methods exposed to us to assert if to assert an expected failure, right? And so let's say this is 2, of course, 2 plus 10 is definitely not equals to 5. So we expect this test to fail, but then if we run these test cases like if you run these two tests like this, oh shit, I don't see. Don't forget, we're expecting this test to fail, right? So as you can see, one test passed, one test failed, right? But this is not a good developer experience. So we need both tests to pass, right? So we can specify an expected failure keyword over here. How much? So this should panic. And then what we're expected it's a method. This basically is a tuple, right? Then we're expecting that 2 should be equals to 3. I'm sorry. Sorry. This is definitely going to be the error is going to return. It should be correct. So this is the tuple specified. So if you run a test, of course, this is meant to fail. This is meant to fail, right? But then the fact that we already expecting that it's going to fail, so it's not going to like run into a panel and it's not going to like run a failure response. It's going to like give a failure response to us, right? So since this pass, that means our logic is also correct. So don't forget, let me comment this out again and run the test. If you run this, it's going to return a fail response to you. But the fact that you're already expecting that it is going to fail and then you added the should panic keyword in your test file, then it's the compiler is going to that, oh, you know that it's going to fail. And you can like so it's expecting okay, it's going to fail, and then it's expecting this error message as well. So once this error message matches what was returned, what is being returned over here, then it's going to like pass, right? So this is also one of the ways to like do a unit testing. Also, so let me quickly touch force testing using the same function. So let's say we have the same test file. Just again here. So test out post. So the beautiful thing with StackNet Foundry is the fact that you don't have to write your, when you're dealing with like the traditional forcing, right? You pass in random figures to make sure that your test breaks. But then StackNet Foundry has made it a lot easier, such that you don't have to like pass these things manually. It like imputes the values at randoms on your behalf. And one of the ways to like do a force test with StackNet Foundry is just like specify that okay, put in arguments here. Put in argument here. So let's say we have test at force. Let's say we have say x is equal to 252. Then we say y also failed 252. Then it's going to send in x and y in here, and we're expecting that the summation should be equal to x plus y. So in this kind of scenario now, right, the compiler is going to pass in random figures in here. Going to pass in random figures, and it's going to like stress the program to find at what points will it break. So if I'm to run this test now, say some forge that. So as you can see, look at the number of runs here. They ran over the program 256 times with arbitrary figures, with random figures, to like make sure that okay, the program works perfectly fine or the program breaks. Sorry, a moment. Sorry, give me a moment, please. Sorry about that. So yeah, so the program is going to like pass in random figures in here to make sure like okay the test passes. So that's basic false testing. So this is the basic things you need to know about false testing. And if you need to know more and stuff like that, the perfect resource is the StackNet Foundry StackNet Foundry documentation. Right here. I think I'm going to send this for the course. So if you need like learn more and stuff like that, you can head over to StackNet Foundry documentations, like see more stuff that are open, more methods that are open for use. So the next thing we'll be touching is integration testing. So basically, it allows us to say know the flow of things. Oh, please, is anyone confused up to this point? Please, if you're confused, signify. Let me reiterate or clarify any confusion. Is anyone confused? Please confirm if you can still hear me.
Yes, we can hear you.
Yes, sir.
All right. So is anyone confused up to this point?
So yeah, I have a question.
Go on, please.
So I'm aware we were using SCAP before to run our programs, and there was a SCAP test function that runs tests. So why migrating to SNForge now for testing, please?
So
I'm just being curious.
yeah. So basically, StackNet Foundry actually like makes a whole lot of things easier, right? A whole lot of things easier when it comes to writing your smart contract and even testing your smart contracts. So, where in the course of the class, we'll be talking about certain cheat codes that are open for use with StackNet Foundry. So basically, StackNet Foundry still uses SCAB under the hood, right? So it's just that the way we're like approaching it is what kind of differs, but then it still works the same way as SCAB does. Is that cool?
Cool.
All right, nice. So let's go ahead to writing. So basically, we want to like do an integration test. So then with an integration test, of course, we need to like have a smart contract, right? So let's quickly create a basic enable smart contract. We are going to be writing this smart contract together, because I'll be asking quite a number of questions to like check how far we've gone with writing smart contracts. See if we can do some magic here. So let's initialize another Foundry project. SNForge init for the moment. So let's create an enable contract. Enable. Set it to enable. Let's open this up as well. Sorry, is there a class governor?
Yes, there is.
Okay.
Let me take it to the line.
Okay.
Do you want to send something to us?
Yeah.
Is Kemi not online? Is Kemi online?
Kemi is online now.
You said?
Okay.
Kemi is the class governor.
Okay. So if I need to send anything, I'll just send it to chat box or directly to class governor. So now we've initialized
Or you can
our
just
contract. What's that?
Sorry. Or you can just send it to our Telegram. We have like a Telegram for this class.
Okay, no
Or
problem.
it's not been added. Yeah.
Yeah. No problem. So we want to like initialize our enable smart contract. Yeah? So the first thing to do, hold on, let's set this. So the first thing we are going to do is to outline what we intend to achieve, right? So basically, we want to have a smart contract that allows only owner to set the data. Also would need a way to obtain the data set. Also, we need a function to return the owner of the contract. What else again? We need the function to transfer ownership. What else? Okay, let's keep it pretty simple so we can quickly, cover up. So where do we go from here? Can somebody help me out? Where do we go from here?
Yeah, we need to define the interface.
Thank you very much. Define the interface. So, Ekarika, what does the interface do? Is Ekarika on the call?
Yeah, I am.
Go on, please. What does the interface do? Are you online or you're on site?
I'm on site.
Okay, good. So what does the interface do?
Actually, what the interface does is it serves as it's where we define all the functions we are going to be interacting with, or we are going to be implementing, or that we'll be using in the contract. So it allows other contracts, or it allows other contracts to be able to use or to be able to call our contract, or to be able to interact with our contract. So it can serve as a middleman, and also it helps guide us to write within what we intend to lay out in the contract. So it serves as a building block, like as a framework or a skeleton, something like that.
So does anybody disagree with Ekarika?
Yeah, I don't disagree with him. Please, your screen size is a bit tiny. Barely see.
About now? Better?
This is better.
All right, good. Okay. So let's define our functions, right? So we need the function to allows only the owner to set data, correct? So let's say we have a function set data. So new passing the value that we want to save, value, which has to be a float to 5. I want to believe that none of us is alien to Cairo syntax, correct? Is that correct?
Yes.
All right, good. So then we've defined our set data. Then we need we need a way to obtain the data set. So have another function set gets data. So well, self taking snapshot first. So it's going to return. Oh, sorry. So
I don't think we need the ref.
yeah, that's correct. Thank you for that. Thank you. Who was that? What's your name?
Emmanuel.
All right, thanks, Emmanuel. Then we need a function to return the owner of the contract. So say function owner. So this also is self. Then returns. Oh, this is definitely going to return contract address, which we've not defined yet. So can anyone help me out? Where do we obtain our contract address?
Yeah, we are obtaining it from the stacknet.
Thank you very much. That's Emmanuel, is that correct? Is that Emmanuel again?
Yes, sir.
All right. Yes. Oh, there's an error here. It's also an error. Right. Awesome. So the last, function to transfer ownership. So if you're transferring ownership, of course, you are going to require a new address, a new owner. So let's do that. Function transfer ownership. So let's oops, no owner. So contract address. Is this good? So is anyone confused up to this point? Is anyone confused up to this point? Signify if anyone is confused up to this point. Are we all clear up to this point? I need feedback.
Yeah, I just have a question.
Go on.
So the ref self, I don't understand what it means. So if you can throw light on
We are
it.
basically referencing the contract state. Do you get that part? We are referencing the contract state. That's why we're specifying this.
Okay. Okay.
Yeah. So, any other question from anybody? So, who else is on the call? Mary Gatoni. So where do we go from here? We're about to start tracking our contract. Where do we go from here? Mary Gatoni, can you help us out? Real quick.
Yeah, after that we'll use I'm on IGSPC, so I think we have to implement the traits now.
We're about
Or
to
the state variables.
We're about to start our contract. Like, what do we do first?
We use the main function.
Wait, anybody wants to help Mary out?
All right, so we need to
Stacknet
actually define
contract.
the stacknet contracts.
All right. So sorry, who was that? Who was that? Who spoke just now?
Was Emmanuel?
Okay. So we need to declare our stacknet contract. Contract. Then we give a so let's say ownable contract. So we define our block in here. I'm just trying to okay, yeah, that's true. So yeah, so according to Mary, then we initialize our storage earlier. We need to specify the storage keyword. We put ours. If I'm going too fast, please bring me back. So yeah. So what do we need? We need a we need a state variable to store our owner, and we also need a state variable to store our data. So so let's say owner. What's the nature of owner? Owner is a contract address. As a contract address. Sorry. Then also our data, the nature of our data is a field 252. So our storage is set. Where do we go from here? Let's define our constructor. Sorry. So, oh. That's not construct one. So, specify the steps. So, so what are we? Okay, we're passing in the initial owner. Let's initialize that from scratch. So we have an zero as an owner. Initial owner should be a contract address. Does anyone see? Oh, yeah, we meant to about this. So we can basically, since we have it up here, we can use it. We can make use of the super keyword. So use super. So contract address. So you don't have to like repeat use stacknet available everything. So you already have it in our file. So let's initialize our owner. So so self owner. Right. So we pass in our initial owner email. That looks about right. Okay, so let's also set our initial data, right? So self dot data, right? We can attribute it variables. Let's just attribute it. Oops. Right, I just uploaded yourself. All right. So, quick question for the class. Yeah. Let's assume that we have let's say data 2 here. So we have data 2 here equals 252. Right, and we failed to initialize this data 2 in here. What is going to be the value at deployment of our data 2? Anybody? Anyone? Oh, okay.
Sir.
All right. So, David, do you agree with Emmanuel? David Dada. Yeah, David Dada. Is that correct? Yeah. Do you agree with Emmanuel? Okay, seems he's not on the call. So, Kemi, Kemi, do you agree with Emmanuel that the initial value is going to be 0, or you have a contrary view?
No, I don't have a contrary opinion. I agree with
All right. All right, let's go. So, where do we go from here? We have our function, we have our interface, we have our storage, we have our constructor. So we should go ahead to our implementation. What is very important. Implementation block. So say enable traits of what's the name of it? Oh, it's on fire here. All right, enable traits to the reference in the contract state. Oh, no. Contract state.
I think we need to use super.
Yeah, thank you very much for that. So we need to import this guy over here alongside here. Yes, this. They're saying it shouldn't be empty. All right, let's go. I think, is there anyone confused up to this point?
No, but do we have to always add the I to the interface, to the name of the interface?
Yeah, it's more like the due process. You can actually do without the height, but then it's more like, okay, it's how everyone writes it, that kind of thing. So so what's our first function in our interface block? So set data. Let's implement our set data. Set data. So ref self. That's since we are progressing this contract state. Contract states. Then what kind of data are we imputing? It felt 252 new value point be felt 252 52. Then what are the features of asset data? Only the owner should be able to call this function, right? So it only makes more sense to first implement our only owner modification first. Let's have a private function. So we don't have to include that. We can use the generate street key instead of creating a not lazy. Generate straight. So does anyone know the implication of the generate straight? Anyone?
It's just for, let's say, implementing an internal function or a private function.
All right. Thank you very much for that. Seven. Let's do this. Say function only owner. So oops. So what would this do? It checks that the person calling the function, right, is the owner. And then there's a method from StackNet to use to get the color of the particular function. So use StackNet. I'm going to use the get color address method. StackNet get color address method. So let's say let color equals get color address. Then we put it somewhere else. Oh, good. So the plan is to check that the person calling this function is the owner. So we can also assert that color is equal to owner. So that's self.read. Self.owner.read. And we can have an error message says color is not free owner. This looks good. Any confusion? Sabo, any confusion? Adewale, any confusion?
No confusion. Okay.
On my side.
How about Adewale?
No confusion.
Okay. So now we can now proceed to like make a check that only the owner should be able to call this set data function. So since this function is a private function, we can equally say self dot only owner. So now this function checks that the person calling the set data function is the owner. If it's not the owner, it's going to revert. So then we can now proceed to set our data. That's right. We passing our new value here. Passing a new value here. Okay, so yeah, I think our set data function is done. Then we can move on to the next function or the next function, get data. Say a function get data. So we can say also say self snapshot of the contract state. Is this contract state? Then is it no? It's only returning something. So basically, what is the nature of okay? It's a felt 252, so it's definitely going to return a felt 252. Felt 252. So, quick question for the class. Hold on a moment. Let me type this out first. So self dot data dot read. So what's the difference between this block, this line 38, and so can anyone tell me the difference between this block of this line of code and this line of code, and this line of code?
So the first one would not return anything because you added like a semicolon at the end. Yeah. Okay. So first one returns data, and I think the second one, I've not used the second one before, but I think it also does same thing, returns the data. Yeah.
So yeah, both does the same thing, but what makes this unique from this? Like what exactly is the main differences between these two, this guy and this guy over here? You can use either one interchangeably, right? Which is very, very correct. But what differentiates this guy from this guy?
I think is the syntax. The first one you don't have to close with semicolon. The last one you close it with a semicolon. That's what is nice there at the moment.
Yeah, it does. Just like the last speaker said, when you close with a semicolon, then you have to put the return statement. That is, you have to explicitly state that you are returning this particular part of this function. But when you don't close with a semicolon, then it will automatically pick it since there's a return there. So it will automatically pick the one that is not closing with a semicolon and return that.
Right. So thank you. So basically, when you make it up a return keyword, you have to like close it with a semicolon. So is that how you use this, or you use this? Is that how you don't close it with a semicolon and return it just like that, or you use the return keyword and close it with a semicolon? Either one works fine.
Okay, I don't know whether this is also the same thing. You know, when
Okay.
you explicitly make use of it, no other program after that can actually execute it.
Yeah, that's right. So let's go ahead. So I see you guys really do have a knowledge of the smart contract. So what's the next function? We need a function to return the owner. For instance, we need to move first step so we can function. Oh, sorry. What is it? Function owner. Function owner. Say the function to return the owner of the contract self. Now contract it's then this is going to return. So the owner is going to return what to us? The contract address. Then we can basically say self dot owner dot read. Yeah. Good. So we have our 3 function sets. So we use how many functions? Okay, so our transfer ownership function as well. Let's implement that. So mind you, this is throwing an error based on the fact that all our definitions here have not been implemented yet. So the moment we implement every single one of these traits in our implementation block, this error is going to go away. So function transfer ownership. So we're writing to state, you have to like make reference to self. Starts with then we can owner, new owner, a contract address. So if you want to open anything, then so I want to make sure that only the owner can transfer ownership. So we can just basically copy this lot here. Just the here. Then so we need to obtain the previous owner first. Are we doing? No, not necessarily. So let's just try straight to it. Do we all know? Do we all know how Emit works with StarkNet smart contract, or we need to touch it? Want to Emit event? Do you all know how it works, or we need to touch it? Quick response, please.
Please touch.
Let's touch
What?
it. Let's touch it.
All right.
Touch it.
So so basically, we want, when we transfer ownership, we need to like emit events, and what do we want the content of the event should be? So let's say the address of the previous owner and then the address of the new owner. And if you want to do that, make use of our emit keyword. If you can just put it like over here. So say our event. Then we need to implement divide, because it's going to like drop it. You have to run into error. Choose event. Then what else? Then we have an email events. So now, what's going to be the content of our event? We already said the previous owner, right, and the new owner. So it only makes more sense to have a structure to accommodate this. So let's implement the same thing here. Say so let's have a struct. So let's name it ownership transfer. Okay. Ownership transfer. Then we can define queue. So say previous owner, definitely going to be contract address. Contract address. Then our second queue. So the new owner, also a contract address. How is this string and all? Oh, sorry, this is going to be just a struct, not an event. Aha, awesome. So now we can confidently make use of this here now. So we can say yeah, sounds about right. So now we've implemented our event. This should work. Yeah. So now the next thing is to make use of this event in our smart contract. So now we know that once we transfer owner, is going to emit an event. So we need the address of the previous owner, and then we need the address of the new owner. Right. So let's say let's previous owner equals self dot owner dot read. So we're doing this first. Okay, then we go ahead to just set it like that. So let's set new self dot now right. So passing the new owner. Right. That looks about right. So let's emit our event. So we have our self, the emit keyword. Then what's the name of our event? Yeah. Ownership transfer. So you can have this here. Positive struct fixing previous owner first. And and the new owner. Yeah. Okay. We are running into an error. Anybody see?
We need to define the
I
key,
think it's
the
supposed
key
to
from
be,
there.
yeah,
Can take one after the other.
Okay,
yeah.
the key should be there actually before the value.
The what?
The key from the struct.
Oh, thank you for that. Thank you very much. Actually, we can do it this way. Previous owner. I guess this alternative should work.
That works.
Yeah, it works. Just for emphasis, All right, so thanks for that. Thank you, Victoria. Thank you, Manuel. So, where do we go from here? I think our contract is looking good. What else have you not implemented? This, yeah, done. So, anybody confused up to this point? Abigail, I don't think I've heard your voice in this call. Abigail, are you there?
Hi, yes, I'm here. I have not heard what you asked, sorry.
Okay, are you on site or you're online?
I'm on site.
Okay. So, where do you think we should go from here? I think we're done with the contract. Well, I was expecting you to say let's just go ahead and test the contract. Anyway, let's just go ahead and test the contract. So,
Yeah.
so we are now going to apply some of the knowledge we had during our unit testing in our integration testing, right? So basically, we could have our test file over here. We just have to make sure we specify the SafeG keyword and SafeG test keyword, blah blah blah. But then for code readability and code neatness, let's have it in a separate file, right? So quick question: have we all deployed on Sepolia? Have you all deployed the contract on Sepolia before? Like StackNet Sepolia, not normal Ethereum Sepolia. Like, have you all deployed on Sepolia before?
Yes, once.
Okay, so can anyone tell me the deployment process? Like the key things that happens before deployment. Because basically we are trying to imitate what happens in real time in our local machine, in our test file, right? So can anyone like explain to me like the processes involved, like the key things that are very, very paramount when it comes to deploying a StackNet smart contract?
So I think it's to declare the the contract before deploying it.
Okay, I think I need to give Daniel a round of applause. Give me a moment. Yeah, I think I just gave you a clap. So yeah, we need to deploy. We need to declare our contracts and then deploy our contract before we can interact with it. Also, are we all familiar with the concept of dispatcher? Are we all familiar with the concept of dispatcher?
Yeah, I have an idea.
Hold on, Kira, before you say anything. Benjamin, do you have an idea of what a dispatcher is?
Yes, I do.
Okay, can you explain it to us? Like, what does
Okay,
it do? Why do we need dispatcher?
dispatcher is like it's like, I don't want to use the word interface because of what interface means in this sense, but it's like the medium we use to interact with a smart contract. So if I want to call the function of a smart contract, I will use the dispatcher of that is generated by the compiler from the trait or interface of that contract to call those functions.
All right. So, Victoria, do you agree with Benjamin?
Yes. Somewhat.
Okay.
So yeah, from the
Okay,
last
want to say
class,
something?
the last class, the tutor said the dispatcher is meant for making external calls.
All right. Of course. Yeah. Of course. So, thank you for that. So, yeah, we already said earlier that we need to declare a smart contract, right? So the beautiful thing is that StackNet Foundry has made this a lot more easier for us. So we can basically just use what's it called? Use the declare keyword from SNForge STD, right? So then I think let's import our dispatcher trait dispatcher. So we can basically say use the name of our project. We are making reference to enable from our test file. Use enable. And the beautiful thing with this is that when we specify this and add a dispatcher keyword to it, it is open for us. Dispatcher. Awesome. Actually, I don't know this is fine. So the truth. Sure. Great. Okay. So these are like, I'm trying to what's it called? Like set up the prerequisites before we proceed to writing our test proper. So now we need to have, let's create, instead of deploying at every point in time that we write a test case, which it makes more sense to have an helper function to help us declare and deploy a smart contract in our test file. So let's say we have a function deploy contract. So this is going to make our testing very easy. Once we have this, we just have to call this function straight up to deploy. Deploy contracts. So not a contract, going to do by tariff. Sorry. By tariff. Contract address. Okay. Okay. So let's contract equals, so we have to declare. So our declare is going to take this name argument. You can unwrap it. Unwrap, is that correct? Yeah, okay, good, compiled. So then we declare, this is how you declare with StackNet Foundry. So then we are open to, so the next is to, after we declare, the next is to deploy, right? So in our deploy contract, the tuple, right? So we can say contract docs deploy docs unwrap. Hold on a moment. So if you can recall, we have a constructor here. So if we don't pass in the argument, it is going to fail. It's going to like throw an error. So it makes more sense to have an admin address. You're passing an admin address, right? Yeah, initial owner. So admin address. So this class is meant to end by 6, right?
No, 7.
7. Okay. All right. Give me a moment. Let's admin address equals. Let's put this. Say admin. Okay, let's typecast this. But then before we can typecast, we need the try into keyword, try into method from core. So I'm sure you're familiar with typecasting, correct? Am I correct? Are we familiar with typecasting?
Yes, yes.
Okay, good. Try into. So can basically do try no into and that works. That one rapid first. No, but unwrap. So since we are typecasting, right, we need to annotate. We need to like tell it that we need you to typecast this into a contract address. Oh, we need to import this again. This is meant to throw an error. Why is it not throwing an error? Hold on a moment, please. Yeah, that's not. Use start notes.
I think the traits.
Okay, what do you think?
They try into core. Yeah.
Identifier not found. It's meant to be from.
I think it has to be like a capital I or something.
Oh, thank you. Thank you. So, okay, this is basically training records. We need to like make a return and stuff like that. So, so now basically this, yeah, we said something about passing in the arguments for the constructor. So it's pass it in as an array. So an array. Then admin address. And this is going to, if we pass it in like this, it is meant to throw an error because it is expecting. So if I class placement. I could not found in contract. So this is a tuple, right? So this is meant to return a contract address to us. And one other thing, they're like 2. So we have to like leave that space open. So this guy won't throw an error. So what's this error again? Of course I did. Hold up a moment. Let's then return contract address. So happen. Something is wrong. I used the variable. Anyone
Nice.
seeing this here?
Can we try spamming the like unwrap?
Say that again.
The unwrap. Do we need to add a spam to it at the end? A spam to it at the end of unwrap?
I know I'm supposed to be actually.
No, not that one.
This.
Yes, but I doubt. No, it's not.
Sure. Not actually. Anyway, let's debug. Let's see where the error is coming from. Can somebody tell me why this is not an error again?
Oh, I see. Is it because the contract address you are returning is not, the type was not there?
I thought it doesn't matter.
I can't see.
Anyway, let's go ahead. If we encounter other errors, we'll debug. But basically, this is our helper function to help someone. Go on.
All right. I see that normally when we want to typecast, we use try into and unwrap. But in this case, you are just unwrapping without just unwrapped in line 9.
Line 9.
Yeah.
Oh, this is meant to. I'm not typecasting here. Trying to is meant to typecast. I'm not typecasting here. I'm just unwrapping what is being returned from declare. If I don't unwrap it, it's not going to go into contract. If I'm typecasting, then I'll make use of trying to. But I'm not typecasting here. I'm just unwrapping what is inside declare. What is being returned by declare in here.
So what is normally being returned by declare? And what's the contract supposed to expect?
Well, let's check the type over here. Okay. Oh, it's not returning the type. I'm not sure the kind of type it is meant to return, right? I've not exactly like looked into that. But probably in the course of the class, if I find it, I'll definitely let you know. Right?
All right,
so all right, go on, Victoria.
Okay, so what's the essence of what you did in line 8? Like, why did you have to typecast the admin to contract address? Why not just use it as normal contract address?
Okay, so it's just basically for readability. You get, I can basically just go on my wallet address, on my wallet, and copy a random contract address, right, and paste it in here, like I code it. But for if you are going through the code base later on, you might be confused as to what kind of address is this. So for basic readability, it's just basically typecasting a string to an address. So if you see this now, you will know that, oh, okay, this is admin address. Or let's say if I have, let's say I have another address here. Let's say fake admin address. Fake admin address. I can basically say here as well. Fake admin. Do you get? It's basically for readability. So this is being typecasted into a string. Sorry, this string is being typecasted into a contract address. Did I answer your question?
So,
are you clear?
Yes. Yes.
So if you say a string is being typecasted into an address, does that mean that anytime that it's trying to fetch that particular address, it will be reading a string as an address? Or will it be able to fetch the deployer's address? I'm
No,
trying to understand.
at this point, this is going to return like an X. Like the returns from this is going to be an X, like it be like a contract address normally. Do you get? So if you
Okay,
try
but
to
not
create,
the deployer's address.
yes, that is the deployer's address. So the owner, this is the owner's address, the one you are passing into the constructor here, the initial owner. Do you get?
Yes, I get this one.
So
But
anytime you,
how will you be able to read that admin is that owner's address? How will you be able to link this admin to that deployer's address?
you mean this?
Yes, how will you be able to link this admin to the deployer's address? The deployer's address.
No. The person deploying this contract now, right? Now, when we run the test case, we run tests, right? It's the inbuilt address, like the inbuilt address, private key and stuff, like that is embedded inside of Stacking Foundry that is deploying this for us. But then meanwhile, if you're familiar with StatsPrank with normal Solidity, we can do something similar, although we can use a different keyword when it comes to this one. So you can specify who deploys this contract address. But meanwhile, we are only passing in the initial owner as at the constructor level. So we are not setting MSG sender over here. So we are passing the initial owner yet. So it doesn't matter who deploys it. Do you get? But then we can still specify who deploys a particular contract. We can make use of Stacknet Foundry's cheat code to get the method that is going to help us to specify who deploys the contract, who calls the function, and stuff like that. Are we good?
Yeah, we are good. Actually, what was confusing me was the fact that this is a script to deploy the contract. Now,
yes.
in the contract itself, we have a constructor that takes in the address, that fetches the address of the deployer and sets it as the owner of the contract. Now, in this script that is meant to deploy that address. Now, if let me put it like this. So let's say we are doing ADAT, we are trying to deploy a Solidity contract with ADAT now. In ADAT now, in our deployment script, we are going to have maybe a kind of .env, and that .env is going to have the deployer's address or private key, and that is going to translate in our deployment script, something like that. Like I'm just trying to like there's a linkage between whatever string we are using in our script to the deployer's address or the deployer private key to just give that connection. Like what I'm just trying to understand now is how does this admin now, how does the script now make it understand that this admin keyword that is here now is a placeholder for the deployer's address.
Don't get it
I don't
wrong.
know if
Don't get it wrong.
okay.
Don't get it. This admin address here is not the deployer. Something else is deploying it for us in our test case, in our test file. This admin address is just being passed into the constructor, so this admin can take the position of the owner. Now, according to our contract logic, we are setting the owner here. We are setting the owner from the argument that we are passing into our constructor, not like we are targeting the deployer of the contract. Do you get? The person deploying this contract is not the owner.
Like
yeah, the admin that passing is the owner. Do you get? Yeah. So I think we are done with our helper function. So now this basically declares our contract, deploys it, and then it returns the contract address of the contract to us, of our Honeybo contract to us. So now we can now move to our test proper now. And then if you want to remember, we were writing our unit test. The first thing we did was to declare our test keyword. Test keyword. And then we say, still the same, let's say test. The first, let's test initial data. We are setting our initial data at constructor level here. So now our initial owner has to be this admin address, and our initial data has to be 1. So let's write a function to test that this state we set over here is valid. So let's say tests initial data. So is anyone confused up to this point before I move forward? Adewale, are you confused? David, are you confused? I need like vocal feedback rather than the emoji, so I can know you're actually following. David, are you confused? David Dada. Is David on call?
Yes, I'm on the call.
Okay, how can it took you so long to respond? So are you following? Yeah. Any confusion so far?
Yeah, I'll watch the playback.
Well, I feel it's best you try and catch up, right? And if you have questions on the go, you ask. Because trust me, when you say we'll go back to it, sometimes you end up not going back to it. So try and catch up and get questions you have. So Banwo, are you confused? A lot of you go Banwo. Are you confused or are we good? So is Fatima a bot?
No, I'm not confused. Thank you.
Oh, great. So is Fatima a bot? Anyway, let's go on. So let's write a function to test our initial data. So let's first deploy our contract. Oh, sorry. Contract. Our contract address is now going to be, so since we already have our helper function to deploy this, and it's going to return the contract address to us, you can basically just call the function here. And mind you, pass in the name of your contract. That's the binary, is it? The name of the contract, so it can pick it up from the target. It has to be the same. If it's not the same, it's going to fail because it will scream that there is nothing like enable contract. So, and then the next thing is we have our contract address now, right? Next thing is to interact with our contract address, with our contract with our dispatcher. So let's dispatcher, oh Lord, dispatcher. Let dispatcher equals to our enable trait dispatcher. We can paste this in here. So what argument does our enable trait dispatcher take? Anybody? Quick response.
The contract address.
Thank you. Contract address. So we have our we can now interact with our contract since our dispatcher is now set up, right? So let's say so now we need to check, we want to test our initial data, right? So we need to check, let's say our initial data in a state in a local variable. Let's say initial data equals to, this is how you interact with it, dispatcher dot, so we are getting data, get data is our function here, get data. So this is going to return our data to us. Sorry, get data. Yeah, get data. And then let's check our initial owner. Let's initial owner equals to dispatcher. No. This, oh no. Dispatcher dot sorry. Where's the owner? Okay. Owner. Dot owner. So basically we know that our initial data is this admin address and the one we passed in here, and one here. So if our logic is correct, the initial data has to be 1, and the initial owner has to be his admin address. So And how can we achieve that? How can we check, make use of the assert keyword? So let's have the same admin address over here because we're going to like check this state. So basically, we want to like test if this initial data, this initial owner data is equal to this admin address that we passed in our deployment, right? So, and also we are going to like check if the initial data is one, the one we passed in like the one we had put it in our contract. So we can easily say assert that initial data is equal to admin address. So if false, incorrect, correct admin.
I think that one should be initial owner.
Oh, thank you. Right. So then also assert that our initial data is equal to 1. Incorrect data. All right. So now let's run our first tests. Let's see how this goes. So you can run your test case by just simply running SNForge test. So it's going to like pick up all the tests that is inside your smart contract. So basically, we only have one test. So we're going to collect just one test. So let's see, that's SNForge test. Yeah, contract compiles. Okay. All right. So why is it failing? Method deploy not found. Oh. Okay. We need to start debugging now. And it does not come. The bug is over here.
I think you have to import deploy or
No, it's meant to be part of this. It's meant to be like part of the method and contract.
The way you imported the SNForge underscore SDT online one and you imported declare, are you not supposed to import deploy also there?
Let's see what talks. Let's see. No. I just find what I have to use. It's not part of its method. Yeah. It plays not part of SNForge STD method. Please, I need more hives to look at this. More hives to look at this. What is possibly wrong? Oh. Let's see. Are you seeing this guy is unused?
Yes, sir.
The same admin address is unused, which is wrong. Oh, contract plus. Not. Next one, what's contract plus? What's the sentence based on this? Okay. Okay. Let's focus. Yeah, good. Yeah. So now, if there is one thing I appreciate with Cairo here, most of the errors, like they are kind of clear with the error now. So let me show you something. Let me take this off again around the error, around the test file again. So now, if you check the error message over here, it says something like the planner found on the type of contract class, like you do import. That's where I got the hint that I did not import the contract class truth, because the deploy method like is meant to be found like in here. So Cairo errors are like quite easy to like trace. You get, so just always learn to go through the error message first and debug from there. So sorry, let's run our test again to see if that works. So yeah, collected one test and then it passed. So that means when we set our state at our constructor level, everything worked as expected. So now let's test for another scenario. So let's test for when we set our data. You know, we sorry. Let's test this function next. This set data function. We already tested the get data. Let's test the set data function next. So let's not forget specify the test keyword. If we don't specify, it won't pick it up as a test. Function tests set data works. Yeah. So now it's still the basic, it's still the same what's it called? It's still the same flow. So you can let's just copy these 3 lines of code. Okay. Then let's set data. So dispatcher dot set data. So now, mind you, this function is going to fail. Oh, paste. Hold on first. Let's test this. Let's test it out. Clear? So as you can see, this second test set data works. This test failed. Why? Now, then this brings us back to Ekarika. Is it Ekarika? Yeah, question Ekarika asked us earlier that how will the contract know the owner from the deployer and the caller of the function, right? So the beautiful thing with StackNet Foundry is that it opens up method to do in stuff, certain things. Like for example, now we want to like let's say say use the address of the admin, like more like maybe like borrow the address of the admin. What's that?
Like prank in normal Solidity, right?
Thank you very much. Yes, thank you for the word. Yeah, more like prank the admin address, right? So let me see. Okay, so this StackNet Foundry, we go to cheat codes reference. So these are cheat codes basically. These methods are available for use. Like use them depending how you want to use it, depending on use case, right? And the guy we need, the cheat code we need over here is this guy over here. So this changes the color of the address for the contract. So now for our can you see my is this bold enough, right? Is it bold enough?
No. Can you see my
No.
Good enough?
Yeah.
Good. So now we need this cheat color address. So now we need function. We need this cheat color address. This cheat color address method for us to like rank the address of the owner, right? And this is a method available for us on StackNet Foundry. So basically, it takes in targets, right? Target contract address, the color address, like the color address we want to rank, and a span. And how do we know what this guy is? If we have something like a span over here, these are like the ways to like maybe debug your test and the things you need, what you don't need and stuff like that. And you can, if you look at cheat span is an enum. It's an enum that specifies how long the target should cheat for, whether indefinitely or for a number of calls. So basically this works perfectly. This is going to work for us. Let's copy this guy. So let's import it. Let's import the guy from SM code std. Is anybody confused? Is anybody confused?
Yes.
You are confused?
Can you hear me? Okay, yeah. So I have a question
you
about.
said yes.
Okay. So I have a
Go on.
question about the contract class that you used the other time. Like, what's the use? Because I understand the use of dispatchers and all that, but like contract class, like what is it needed for?
So this guy basically allows us to have access to methods like deploy. So when this contract class was missing, this deploy method did not work because we did not implement the trait in our own smart. It has been implemented from StackNet Foundry, right? So we only need to like bring in the trait into our own local machine for us to make use of the deploy method. So without this contract class trait, we will not have access to the deploy method. If you notice this declare came straight from SNForge STD, right? So does deploy. We could not import deploy directly from here, just saying we deploy declare. The way we imported declare, right? So we needed the contract class trait so that we can have access to the deploy method. So without this contract class trait, we cannot have access to the deploy method. It's not like you saying that you want to call set data without importing a boot trait. Like the way we've been calling get data over here, right? This was only made possible because we imported this our enable trait dispatcher, right? It's almost the same. You get so without the contract class trait, which has the implementation of the deploy, there was no way we could like make use of the deploy method on our contract. Do you get?
Yes, I do. Yes. And also, yeah, a follow-up question, right? So yesterday, Wednesday. So the method was like dispatchers are generated automatically for your contract, like each contract you write. Because I see that it's coming from Onable, and we did actually declare it in Onable. So it's coming, it's being generated. Like, how is this generation process? Like,
no, that is very correct. That is very correct. Yeah, it's being generated to us under the hood. And believe me, technically, we cannot go into the details of how it is being implemented under the hood. You get? So that has been abstracted. All we have to do is just make. It's just the same way. If you notice here, this private function here too. that function we have here, we just have a generate trait. All this, it generates the traits under the hood for us. We don't have to like necessarily, since we are staying on the application layer, we don't have to like necessarily like maybe know like the into unless you want to like maybe dive deep into it, then you can go ahead to like check out how it works under the hood. You could take it as a personal project anyways.
Okay, I'll do
So,
that. Thank you.
all right. So let's go on. So now we need to prank the address of the admin for us to be able to call this set data function. So we already imported the cheat caller address. Cheat caller address, right? So the way you use stat prank, right? You have to like put it above the function you want to call. Although we can specify the number of calls we want this function to the number of calls we want this caller to be able to like call, right? But then we start to like specify that, okay, just put it above the function you want to call. And then what are the parameters? Takes the target control address, then caller address, and a cheat span. So the target is the address you want to interact with, which is this contract address. So this guy over here. Then it takes in the caller address, the person that you want to be the caller of the function, that's the admin here. Then it takes in a span, which is cheat span. I don't know. So cheat span is an enum, right? So let's import cheat span over here as well. Also able to make use of it. So we can pass in cheat span. Yeah. So we can set it to indefinite, or we can just say, okay, make only this number of calls. So let's just say we wanted to make just 2 calls. Targets and 2 calls. So if we want it to be indefinite, we can just pass in indefinite over here as well. It does not take in a parameter, only target calls takes in a parameter. Sorry, an argument. I think this is good. So yeah, I think this is fine. So let's test this first. Let's see if it's going to, if it works first before we proceed with the rest of the test logic. Oh, this is semicolon. Okay, great. Oh, awesome. So yeah, we've been able to successfully prank the address of the admin. That was why we were able to call this set data. So we need to be sure that the data actually is correct. So our new data now is going to be 6, right? So we need to like check if truly it is 6, since we are setting it to 6. So let's say let's new data equals to dispatcher dot get data. Right. So then we can put in a little assert statement over here. New data is equals to 6. If it is not, then data set will. So let's clear this. We're gonna test over again. Good. So yeah, our test works now. Any confusion up to this point?
No,
Man,
no.
I kind of lost it from where we started using this sheet thing.
Okay.
I don't know if you could quickly run through it again. I'm sorry, please.
Okay. No problem. So cheat caller address is a cheat code, like a cheat sheet from StackNet Foundry that has been implemented already on StackNet Foundry. All you can, and then you have access to make use of it in your test file, right? So basically, what it does is to mock the address of the caller, like the person you want it to be the caller of that function. It pranks it. It works similar ways the way start prank, stop prank works in Solidity. So this guy allows you to prank an address that you want to be the caller of a particular function. So now we want this admin address to be the caller of this function, right? So we can invoke the cheat caller address method, passing the target caller the caller address you want to you want to interact with, passing the person you want it to be the caller, and then passing the cheat span, like the span argument. So basically, this span argument, the span argument is for the document. You can see it from documentation, like over here. It takes in the cheat span. It takes in the span. It takes in three arguments: target, caller address, and then span. Right. And then we further now, when we search cheat span here, of course, and we further now found out, okay, what exactly is this, or is this cheat span? So we found it over here. Then we realized that cheat span is an enum that has two options. You know the way enums work? If their option is it's either A or B, depending on the definition of the enum. So it's either we say, okay, it is we want to choose indefinite. We want the caller to call an indefinite number of functions, or we want the caller to only call a few or a certain number of functions. So then we pick the target call. So let's say we want to pick indefinite now. Let's say we pick indefinite now. Yeah. If we pass in cheat span, and don't forget we first imported cheat span from StackNet Foundry. This cheat span, we imported it here first because, of course, it is a method in StackNet Foundry, right? So we first imported it, and then let's pass in one of the options inside the enum, which is indefinite. We made use of target calls earlier, so let's make use of indefinite and see if that works. So now, by implication, when we set this, that means the caller of this set data function is going to be the address that we specify in it, which is the admin. We expect it to pass. So is it clear now, Emmanuel? Emmanuel, Carlo asked the question.
Yeah, it's clear.
All right, awesome.
Sorry, I just want to see I just want to see where you imported your cheat caller address from, because if I do it on my system, it keeps failing. I don't know why.
Okay, imported it from StackNet SM4 yesterday.
That's the same thing. I don't know. But if I do start prank, it works. But if I do this cheat caller address, I don't know why it doesn't work.
Oh, what's the version of your StackNet Foundry? I'm using the latest version. There has been upgrades. Start prank works on previous versions.
Okay. Let me try and update system.
Yeah. So any other confusion from here? At this point. I need a verbal feedback. Any other confusion from here? Are we all good?
Yes, sir.
Yeah, we're good.
So let's test one more scenario. Okay, so let's test if a fake admin tries to wait, hold on. Okay, let's test if a fake admin tries to maybe interact with set data, right? So it's basically this guy. It's basically this guy. We want to make sure that no other admins can call this set data function. So let's just copy this function here. So let's call it tests fake admin set data fields. So, fields, right? So technically, let's replace this guy with fake admin. Let's say fake admin address, and let's call this fake admin. So it deploys sets the admin, blah blah blah. Then let's copy this, and you want this fake admin address. This fake admin should be the one to like call this function, right? So let's delete this as a footnote because we don't need it because we know it's actually going to kill. Oh no, let's leave it. Let's say, let me say, so since the data will remain unchanged, so just to be sure that the data we set at deployment remains the same. So let's say data check, and the data check is 1. The initial data we set at deployment is 1. So so by implication, if this function should go through, right, and the person is able to like set data to 6, then there's a very big problem with our contract. There's a very big vulnerability with our contract, right? So this is meant to fail. So let's clear this. So as you can see that, okay, one of the tests failed with the error caller is not the owner. So that means, yes, our contract works, right? But then there are better ways to handle all the failed tests, right? If you can remember, if you can remember when we're talking about our unit test cases, right? We had an option that allowed us to test, or is it? An option that allowed us to, give me a moment, sorry. We had an option that allowed us to ascertain that, okay, this test should fail. You should like panic, right? It's instead of like, handling, okay, failed in your console and stuff like that. Better ways to like handle this. So we need to expect a panic message, right? So let's set it over here. So sorry, I just will copy from that. Start it from there. So yeah, but then mind you, we're expecting this function to fail like this, right? But then we want to like make sure that we don't get this fail message in our console. So we're expecting that caller, it should return an error saying caller is not the owner. So if we copy this and paste this in here, and then run it all over again, then we would have handled our failed error message properly. Give it a moment. As you can see now, we no longer have a field test again because we're ready to the compiler to expect that, okay, for this test, return an error saying the caller isn't the owner. So it's already like proven that, okay, once this test run and then it returns that caller isn't the owner, then we can pass. So I'm guessing this is settled.
So can we test the enums to see if they emit what we expect? Is there a way we can test that?
Oh yeah, that's true. We can actually do that. I have to like take sorry, give me a moment. Okay. So let's do this. Let me send something in the chat box. So I just sent something in the chat box. In your, it's actually going to be part of your, what's it called, your exercise. So go on the documentation and figure out how to test smart contract events. So although I have an exercise for you guys to do right now. I'm going to push this contract. Okay, let me do this. I'm going to create a gist file right now. I'm going to paste in the Cairo contract and then the test contract, right? And you guys are going to write two more functions. Two more test cases. Yeah? Two more test cases. One is, okay, hold on. Let's have it over here. Wait, were we coding along?
No.
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 Okay. So I'm going to push this right. To do so. Say one write the following test cases. One test if transfer ownership works. Transfer ownership works. Then also test if transfer ownership by a fake admin works. So that test scenario can we test? Can we test on my web if the power works? Put up. Okay, and the take home. So you'll be doing this. Within these two on call right now. You would have only about say 30 minutes to get that done, right? Only about 30 minutes to get that done. So you have to think fast. You only have 30 minutes to get it done. So then the take home, this one will be submitted. Today is what? Today is Friday. So this is going to be submitted tomorrow. Sorry, you have a class tomorrow, right?
No.
Okay, beautiful. So this second one is going to be submitted tomorrow by 4 p.m. Any submission?
Sorry, sir. Hello, sir.
What's that?
Sorry, sir. I really like to come here and please because I don't know for others, but for instance, I still have last week we had some outings and stuff. So my catching up with Cairo is still a bit behind. It's because of the assignment I'm speaking. It's still a bit behind. And not to talk of this, the fact that we have like two hackathons that are closing in. I know it's not like we are submitting and we are sure, but then we're trying to just push to just make sure that we have it submitted, and that's and then we have another one to be submitted. So I don't know if you would actually give us more time so that we can actually put much effort in making sure that we get to. We don't want to just rush it and just do it just for doing sake and have it done, but we want to make sure that we know it and we know it well. So if you could actually give us time so that we can clear out all our. In fact, we still have one assignment from Wednesday that I've not even touched it. There's another assignment again that I've not even touched, and I just have to plead like if you could just temper justice with temper mercy with no temper. I don't even know one temper, sha. Anyone just temper justice with mercy. Yes. So if you could just help us, please, sir.
Okay. No problem. No, I can't do this one. Hold on a moment. So, I understand your concerns, right? It's one of the reasons why you're in the three bridge. You need to learn how to multitask. But given the fact that you pleaded and stuff like that, so you can now submit it tomorrow by 4:30 instead of 4 p.m. I think that's fair. So give me a moment. Let me push this to GitHub Gist. I need to log in my details first. What is it? Good. So yeah, you are doing this on call right now, and you have to like think fast. You have only 30 minutes to get it done, and then you push it to you create a gist, push it there, then you submit it on your. I'm not on the Telegram group page. Classweb, I have been on Telegram group page. Classweb.
Yeah, I'm trying to reach out to the admin to add you to it. Is that
Okay,
fine?
so do that. So yeah, yes.
All right,
So
no
do
problem.
that. So that once you guys are done, you submit it like there. Then we review it within 5, 10, 15 minutes. Cool. So I think I should stop recording now.